Today we are going to talk about scale factor and how it affects measurement of figures. The first thing that I need you to do is take your foldable and cut it down the middle so that you have these triangles on one half and the prisms on the other half. Once you have done your cutting, I want you to glue the triangles on the left side of your composition book, the prisms on the right hand side of your composition book. Let's start by reviewing scale factor. A scale factor is a multiplier. Let's look at the triangle below. I have a small triangle that has sides of 8, 8, and 10, and I want to apply a scale factor of 2 to create a larger, similar triangle. So I take my side lengths of 8 and 8, and I multiply them times my scale factor of 2 to get the new side lengths of the larger triangle, 16 feet and 16 feet. Then I would take my base length of 10 and also multiply it times the scale factor of 2 to get a new base length of 20 feet. Let's see how scale factor might affect the perimeter of the figures. So I'm going to find the perimeter of the smaller triangle by adding the sides 8 plus 8 plus 10, because if you remember, whenever I am finding perimeter, I am looking for the distance around the outside edge of the shape. So I add 8 plus 10 to get the perimeter, the distance around the outside of the triangle, to be 26 feet. Now I'm going to do the same thing for my larger triangle, going to add the distances of each of the sides of the triangle to determine the perimeter around my larger triangle. So I'm going to add 16 plus 16 plus 20 and find that the larger triangle has a perimeter of 52 feet. Now let's compare the perimeters. Is there something I could multiply 26 by that would give me the perimeter of the larger triangle 52? To determine this, we take the perimeter of the large triangle 52, divide it by 26, and we find that the multiplier that can be used between the perimeters is 2. I want you to note that my scale factor between the lengths of the triangles and the scale factor between the perimeters of the two triangles is the same. They both have a scale factor of 2. Now let's see how scale factor might affect area. I have two circles here, a smaller circle and a larger circle. We are going to say that the smaller circle has a radius of 4 feet. And we're going to apply a scale factor to the radius of 3, making our larger circle radius of 12 feet. Now we're going to find the area for each of the circles. Remember that when I'm finding area of a circle, I'm going to multiply pi times the radius squared, and I want you to leave your answers in terms of pi. So pi times 4 squared gives the smaller circle an area of 16 pi feet squared. Pi times 12 squared gives the larger circle an area of 144 feet squared. We are going to compare the areas of the smaller circle and the larger circle and see if we can find a multiplier, and then look at how that multiplier compares to the scale factor we used on the radiuses. Let's start by trying the scale factor of 3. 16 pi times 3 would give me 48 pi, but my larger area is 144 pi, so we know that that is not the multiplier that we need. So if we take 144 pi and divide it by 16 pi, we are going to get 9. So when I take 16 pi and I multiply it by 9, I get the larger area of 144 pi. So let's compare the scale factor. The scale factor between the radiuses is 3, whereas the scale factor between the areas of the circle is 9. Now let's look at how scale factor might affect volume. We have a rectangular prism that has dimensions of 2, 3, and 2, and we are going to apply a scale factor of 2 to each of those dimensions. So I have my third dimension, or my thickness of 2, I multiply it times 2 and I get a new thickness of 4 feet. I have my length or my width, whichever one you want to call it, of 3, and I multiply it by my scale factor of 2 to get the new length of 6 feet. And I have my final dimension, my length or my width, depending on what you want to call it, of 2. I multiply it by my scale factor of 2 to get a new width of 4 feet. So, volume of a rectangular prism, if you remember, is the area of the base times the third dimension. The area of the base of a rectangular prism is the area of the rectangle, so we're going to multiply 2 times 3, there's my area of the base, times 2, which is my third dimension, or my thickness, to get a volume of 12 feet cubed. For my larger rectangular prism, I am going to multiply the area of the base, so I am going to do 6 times 4 times the third dimension of 4, and I get a volume of 96 feet cubed. So let's see if we can find a multiplier that I can multiply my smaller volume by that will give me the larger volume. We can start by trying the scale factor we used on each of the side lengths. If I multiply my volume of 12 times 2, that only gives me a volume of 24, which is not equivalent to my 96 feet cubed. So we will do like we did with area, and we will divide our volume of 96 by 12, and we get a multiplier of 8. So the scale factor between the volumes is 8. So let's look back at what we have done so far. First, we started by comparing the perimeter of two triangles. Whenever we are finding perimeter, we're dealing with a one-dimensional measurement length. We're finding the length around. So I put a little exponent of 1 because all of my units of measure when I find perimeter are to the first power. We just don't ever write that 1 there. So when I took my triangles and I applied a scale factor of 2, the changes in the perimeter also had a scale factor of 2. So whenever you are applying a scale factor to the side lengths that are affecting circumference or perimeter, you can find the new circumference or perimeter by multiplying the original perimeter by the scale factor, and it will give you the new perimeter. Whenever I'm finding the area of a figure, I am multiplying two dimensions together to figure out how much space that figure covers. That is why my units of measure for area are always squared, and that is why the little 2 is here with the area. So when I took my scale factor of 3 and applied it to the radius of the circle, the change in measure of the area between the two circles had a scale factor of 9. Whenever I take 3 and I square it, I get that scale factor of 9. Have the area of a smaller figure and I'm applying a scale factor, I can square that scale factor, multiply it times the original area, and it will give me the area of the new figure. Let's look at what happens with volume. Whenever I am finding volume of a figure, I'm multiplying 3 dimensions together, which is why my units of measure are cubed. So when I took the scale factor of 2 and I applied it to each of the dimensions of my rectangular prism, the change in volume from smaller prism to larger prism was 8. My units of measure for volume are always cubed. 2 to the third power gives me that change in measurement between volume of 8 So if I'm given a scale factor and I want to apply it to the volume of a figure, I would take the scale factor, cube it, and multiply original times the scale factor cubed, and it will give me my new scale factor.